This is a simple elevation map of Mars' surface, from data gathered by the Mars Odyssey spacecraft. The South Pole, colored in orange and red, is piled high with ice that comes and goes with the seasons. Moving off these southern islands, we make our way north. The landscape is pocked with craters. The largest and oldest ones have slowly faded, softened by wind-blown dust. We now pass into the Tharsis region along the equator. Here, on a wide, high plateau, are a series of enormous volcanoes, including the largest one in our solar system, Olympus Mons. Just to the east is the great Valles Marineris. It's named for the Mariner 9 mission that found this vast gash in the Martian landscape. It's about 2,500 miles long and up to 400 miles wide. Dust devils sweep along the plains above it. And dust blows up the valley slopes. We can see this incredible landform in a realistic rendering of the data. Giant landslides have caused the walls to slump off and pile onto the valley floor. Feeding into this valley, a maze of side channels. Scientists think these and other tributary features were formed when water underground flowed into the main basin and the land above collapsed. Wider parts of the canyon are regarded as possible landing sites for human missions. They offer flat surfaces and possibly access to liquid water that may remain below the surface even today. From the layers of rock that line the canyon walls and layers of dust on the canyon floor, future science prospectors can fill in the details of the planet's history. The theory is that the great Valles Marineris formed early in Mars history as the planet cooled. Its huge sides were ripped apart as the Tharsis region, just to the west, began to rise up. But there seems to have been another, much larger event that changed Mars' course forever. Travel north, down the slopes of Mars' great volcanoes. The elevation drops as we dive into what appears to have been an immense ocean, with this vast basin in the north. And the very high elevations of the south, Mars is a lopsided planet. And here's why. Early on, when the solar system was young, Mars was apparently hit by at least 15 large asteroids. One of them was large enough to turn most of Mars' northern hemisphere into one huge impact feature. Earth, too, was followed by objects this big, but because Mars is small, only about half the diameter of Earth, and has only about a third of Earth's surface area, the effect would have been much more profound and long-lasting. The thinking is that these impacts heated the outer subsurface layer of the planet, the mantle. That prevented molten rock in its core from rising up, and switched off Mars' magnetic field, probably forever. Without its electromagnetic deflector shield, solar radiation began to lash the planet, gradually stripping it of its atmosphere, and thus its blanket of warm air. What water Mars had would have vaporized into space, or frozen underground.